What is logarithm? Logarithm is the power to which a number must be raised to give a particular number. Let's look at this expression, log x base a. Okay, the logarithm of this number is the power to which a, which is the base of this logarithm, is the number to which it must be raised to. It's the power to which this a must be raised to give you this x. So what it means is that if we say the logarithm of x is y, it means the power to which a is raised to give you x. That is what logarithm is. There are different rules used in the evaluation of logarithm, and we'll be talking about those rules one after the other. The laws of logarithms. I'll start with law number one. For an expression log mn base b, this can be written as log into base b of m plus log into base b of n. Okay. For example, if you have log if you have log 4 times 8 into base 2, this is the same thing as log 4 base 2 plus log 8 base 2. Okay, let's talk about the law number 2. If you have an expression of log m divided by n into base b, this can be written as log m into base b minus log n into base b. Let's look at an example. If you have log 8 divided by 4 into base 2, this can be written as log 8 base 2 minus log 4 base 2. Okay, let's look at law number 3. If you have an expression that says log of m raised to power k into base b, this can be written as k times log of m into base b. What we just did is we bring here this one here and use it to multiply the log of m into base b. Okay, for example, if you have log 8 into base 2, okay, this can be rewritten as log 2 raised to power 3 base 2, and this can be rewritten as this 3 can come here and it becomes 3 times log 2 into base 2. Okay, let's look at number 4. If you have a logarithm expressed as log m into base b, this can be the same as log m base k divided by log b base k. What this just do is that there are sometimes you may need to work with different logarithm. If you want to convert all of them into the same logarithm, that's when you will usually need this expression. Okay, for example, if they give you expression in logarithm of base 2 or base 3 and another logarithm into base 6, if you want to work with them in the same base, you can convert all of them to base 10 to make it easy for you. Okay, and this is the way you can convert bases into another base, where k, this k will be the common base, will be the base that you want to work with for those logarithms. Okay. Now the next law we'll talk about is when you have a logarithm of x to base x, meaning that the logarithm of number into the base of the same number. This is usually equals to, this is equals to 1. Okay, that's the rule. Rule number 6, when you have logarithm of 1 into any base, is usually is equals to 0. How do we arrive at log of 1 into any base is equals to 0? The reason is simple. If you watch my video on indices and the laws of indices, you will realize that any number raised to power 0 is equals to 1. So if we consider this to be log x, where x is any number raised to 0 into base a, you know, this is equals to 1, right? So it's the same thing as this. Okay, it's the same thing as log 1 into base a. Okay, so if you evaluate this, this will be equals to 0 according to this rule here. According to this rule here, if you have a power of a number that you want to find its logarithm, you can bring it here and it will come and multiply the logarithm. So it will be 0 times log x into base a. So this will be equals to 0. That's why log 1 into any base is equals to 0. Okay, let me add another expression to it that will help you when you are evaluating logarithm. If you have an expression like this, log x into base a, if they say is equals to y, okay, this can be evaluated as this. The base will come and carry this y as its power, like this: a raised to power of y is equals to x, and you can discard the logarithm. So these are the rules that we'll be using in doing the calculations that we'll be doing in the exercises and examples that follows. Before we go, I want you to know that the same way this can be converted into this, the reverse can also be the case for each of these rules. Okay? The reverse can also be the case for each of the laws of logarithms. The reverse can also be the case. Okay? Now, let's start applying these laws into some example. I'll start with example number 1. Evaluate log 27 into base 3 plus log 6 into base 3 minus log 54 into base 3. Before I go, I need to let you know that if you have an expression like this, if you look at the laws of logarithm, we can express this as logarithm into base 3 for all of them, okay, of 27. Because this is plus, this will turn into multiplication 6. And because this is minus, this will be all over 54. Okay? So 27 here 1, 27 here 2, 2 here 1, 2 here 3. So this is equals to log 3 into base 3. If you have a number, if you have logarithm of a number that has the same base with the number, this is equals to 1. You can check the rules, the laws of logarithm that I talked about. Okay. Now let's look at the second example. They said if a is equals to x raised to power 1 over n. Okay. They say find log x raised to power n into base a. They say we should find this. Okay. Now let's say let's represent this by y. Let's say log x raised to power n base a that they say we should find this one. Let's say is equals to y. Okay. Now from the last rule I talked about earlier, this can come to this side and carry y as its power. So we have x raised to power n is equals to a raised to power of y. Okay. Now they told us that a is equals to x raised to power 1 over n. Let's substitute, but a is equals to x raised to power 1 over n. Let's substitute in the equation. Let's substitute it in this equation. And if we substitute it, we'll have x raised to power n is equals to x raised to power 1 over n, okay, bracket y. Okay. So if you remember the rules of indices that I talked about, you can watch my video on the laws of indices. You will find it in the link that pop up above. This can be simplified as x raised to power 1 over n times y. Okay. And when you have base number on both sides that are equal, you can discard the base numbers so that you now have n is equals to y. N is equals to 1 over n times y. So your n is equals to y over n. So if this comes to this side, it will become n times n is equals to y, right? Therefore, n squared is equals to y, which means y is equals to n squared. So this is your final answer. So what this simply means is that since we represented this our equation with y, what simply means is that our equation log x raised to power n base a is equals to what? N squared. Let's look at another example. Example 3. They said that we should evaluate log 0.04 into base 10 plus log 0.25 into base 10 all over log 100 into base 5 minus log 4 into base 5. Let's evaluate this. If we look at this very well, since logarithm is adding each other here, this can be re-expressed as common logarithm into base 10 of 0.04 times this one 0.25, okay, divided by log into base 5 of 100 divided by 4. Okay, if you remember recall the rules of logarithm that we talked about earlier here. So this can be expressed, it can be re-expressed as this can be re-expressed as log into base 10 of 4 times 10 raised to power minus 2 times 2.5 times 10 raised to power minus 1, right? All over log 100 divided by 4, 25 into base 5. Okay? Now, if we look at this, we can re-express them as log 4 into base 10 plus log 10 raised to power minus 2 into base 10 plus this log 2.5 into base 10 plus log 10 raised to power minus 1 into base 10. Okay? All over log 25 is equals to 5 squared, right? Into base 5. Okay? Now, if we evaluate this, we can see that some of these things have the same basis. We can bring this one into here, okay? And bring this one to here and bring this one to here so that we can get log 4 into base 10 plus, now this one is coming to multiply this, minus 2 times log 10 base 10 is equals to 1, okay, plus 2 log 2.5 into base 10 plus, let's break this one here, that will be minus 1 times 1 because log 10 to base 10 is equals to 1. Everything divided by 2 times 1 because log 5 into base 5 is 1. Okay? So if we evaluate this, you can see that we get minus 2 minus 1 here. That will be equals to minus 3, right? So we will have log 4 into base 10. Let's bring this one here plus log 2.5 into base 10 minus 2 minus 1 all over 2. Okay? And this can be re-expressed as equals to log 4, okay, times 2.5 all into base 10 minus 3, okay, all over 2. Okay? Now, if we say 4 times 2.5, that will be equals to 10, right? So that we'll be having, this will be equals to log 4 times 2.5 is equals to 10 into base 10 minus 3, everything all over 2. And this will be equals to, since this is log 10 base 10, that will be equals to 1 minus 3 all over 2. Okay? And this will be equals to minus 2 all over 2. 2 here 1, 2 here 1. This will be equals to minus 1. So this is our final answer. Let's look at another example. They said you should find the value of 4 raised to power half plus log 0.04 base 5 plus log 81 base 3. From the rule of indices, we know that 4 raised to power 1 over 2 is equals to root of 2, root of 4, okay? Plus this can be expressed as log 4 raised to divided by 100, okay, base 5 plus log 3 raised to power 4 into base 3, okay? Now, if we simplify this, 4 here 1, 4 here is equals to 25. Now, we have root 4 is equals to 2 plus log 1 over 25 into base 5 plus log 3 raised to power 4 into base 3. Now, this one can be expressed as 2 plus log 25 raised to power minus 1 base 5 plus log 3 raised to power 4 into base 3. Okay? Now, this one can be re-expressed as 2 plus log 5 raised to power 5 all brackets minus 1 base 5 plus log 3 base 3 log 3 raised to power 4 base 3. Okay? Now, if you, from the rules of indices, this will be equals to 2 plus log 5 raised to power 2 times minus 1. That will be minus 2 base 5 plus log 3 raised to power 4 base 3. And this will be equals to 2 plus, from the rule of logarithm that we talked about earlier, this can come here and this can come here. And this one, log 5 base 5 will be equals to 1. So that will be minus 2 times 1, okay, plus 4 times 1, okay, and this will be equals to 2 plus 1 times minus 2, that will be minus 2, okay, plus 4, okay. 2 minus 2 cancel each other and the answer is equals to 4. This is the final answer. If you enjoyed this video, kindly like, subscribe and share with your friends for them to benefit. After subscribing, you can click the alert bell for you to be notified when I upload new videos. Till I see you in my next video, bye bye and take care.